Hello. Back to doing some math here today. Moving on to chapter 8. This is chapter 8, focusing on exponentials and logarithms. The focus overall is logarithms and logarithmic functions. So last chapter we dealt with exponentials, and the cousin, or actually the inverse to an exponential, is a logarithm. Let's get a feel for what's going on here first with the whole definition of logarithm and some of the properties, and then we can look at it functionally. I believe the book kind of goes at it a little bit different than this, but you get the general idea. First of all, this word logarithm really means exponent. So when you hear logarithm, you need to think along the lines of an exponent. There are two ways of dealing with logarithms. There's log form or logarithm form, and then it's exponential form. Any equation can be written into a log form or into an exponential form in general. So this is kind of something that maybe has been hidden amongst all the equations that you've been working with up to this point. But let me give you the basic form for a log. A logarithm has a number that would be considered what it is that you're taking its base of, so to speak. And so here, let me just show you this. A log form would be like log base b of, and I want to be consistent with what they do in the book. I don't even know if they do a general form in the book. Well, we'll just do it like this. Log base b of x would be equal to, let's say, y. Okay. So logarithm is a function, and it's a function of finding exponents of given bases. So it's taking an exponential and it's inverting it. And you'll see that on the calculator. We're going to show that on the graphing calculator, how they are actually inverses of one another. So if we have the log form, log base b, that's going to be a numerical value of another number, x. It is calculated and found to the exponent of y. And I say it that way because a lot of times as students, this all looks kind of foreign and mystical, and it's really not. All we're really doing is trying to figure out what's the exponent that would make this true. So y would in essence be that logarithm. It would be that exponent. So taking it into its exponential form should open that up and make sense and kind of demystify it to an extent. So if this is your log form, the exponential form of this would be, what's your base? So this is going back to your basic algebra life. So we have some number that's being raised to an exponent. So base b raised to our exponent or our logarithm, b to the y would be equal to x. So they're just working in conjunction. One represents the other in its different form. Functionally, they're quite different. They're inverses of one another. So I don't want you to think like logarithm means exponent. It means exponent in terms of its form. So here's an example. If you take the log base 2 of some number, let's call it x, and that was equal to 3, what value would x need to be to make this true? Well, to answer that question, we go to its exponential form. So we rewrite this logarithm into its exponential form. So from log form to exponential form, it would look like this. What is the base? Well, the base is that number that is subscripted with the logarithm. So our base in this case would be 2. And so if we put it into its exponential form, we're going to raise it to its exponent or its logarithm, 2 to the third is what x would need to be for this to make sense. So you can say, well, what's 2 to the third? 2 times 2 times 2. Well, that's 8. Okay, well, x equals 8. So in other words, you could write this as log base 2 of 8 would have to be 3. And the reason why is because our base 2 to the third power would equal 8. Okay, so there's your introduction to logarithms and exponentials. So from log form to exponential form, working back and forth. I'm going to give you some examples of how this works here in this next video. All right, see you guys in the next one.